All right, guys, so for class today, since it's an asynchronous version of what I did yesterday with first period trig, we're going to do the warm up together. Then we're going to do a practice problem together. Then I'm going to have you submit a problem, so do kind of an exit ticket. Submit a problem on Schoology as an exit ticket, and then you're going to have the rest of the period and the weekend and so on to work on your homework that I showed you guys yesterday. So this first problem, this was the warm-up. I just want you to solve for x, okay? And I've got the steps right here of how we need to do this. So if you would like to see where you stand on doing this, I would recommend pausing this video and trying this on your own and see where you get. Okay, our first step is to multiply all terms by the least common denominator. In order to multiply by the least common denominator, there's a little bit of a caveat there. We need to first find the least common denominator. Now remember, to find the least common denominator, what you normally do is you factor all the denominators, you take anything they have in common and add it once, multiply it into the LCD once, and then anything left over you also take once. In this case here, all the denominators are already factored, right? We can't factor any of these more. I mean, I guess you can make this 2 and 2, but all of these are in factored form and they have nothing in common, right? There is nothing in common here. So our LCD is actually going to be x times x minus 1 times 4, okay, because there's nothing in common. So the next step would be to multiply each term by the LCD, right? Multiply both sides, all the terms by the LCD. Now we're not multiplying the numerator and denominator like we did when we solved for expressions, because this is an equation. We just need to keep it balanced. The goal here is to keep the equation balanced. I could multiply, the numerator and denominator. That would be fair. It would work, but it's not going to get me anywhere. The whole goal of what we're doing here is to cancel the denominators, right? When we solved simplified, I should say, expressions, our goal was for each term to have the common denominator, because then we could combine them. That's not our goal here. Our goal here is to eliminate the denominators, have no more fractions left. So what I'm going to do is rewrite this. We'll have 4x minus 1 times 6 over x, 4x minus 1 times 9 over x minus 1. And you don't want to multiply any of this out, because the idea here is that stuff is going to cancel. So you want to leave it in factored form. 4x times x minus 1 times 1 all over 4. Right? And you should be able to see, well, here I've got x divided by x, so those will cancel out, and I'll be left with 4 times x minus 1 times 6. Here I've got x minus 1 over x minus 1, so that's going to cancel, and I'll be left with 4x times 9, and then here 4 over 4 cancels, so I'm left with x times x minus 1 times 1. Right, now I can multiply out and simplify. So I'm going to have, this is going to become 24. So 6 times 4 is 24. That's going to be 24x minus 24 minus 36x equals x squared minus x. Now this is a quadratic, and whenever you have a quadratic, you should know that, okay, I need to get everything equal to 0. So I'm going to bring everything to the side with the x squared. So first we'll combine like terms, and we'll get that negative 24 minus 12 equals x squared minus x. I'll add 12 to both sides, add 24 to both sides. That's 12x, sorry. That's going to be 0 equals x squared plus 11x plus 24. That factors really nicely because it has a leading coefficient of 1. You're really just asking yourself what's going to multiply to a positive 24 and add to a positive 11. That's going to be 8 and 3. So then my two solutions are x equals 8 and 3. Okay, so far we multiplied all terms by the least common denominator. We canceled what could cancel, right? Lots of stuff canceled. You don't want to multiply out until you cancel, because then you can algebraically solve the rest. You should always be left with either a linear or quadratic equation to be able to solve. And then last but not least, we need to check our answers in the original. So in 6 over x minus 9 over x minus 1 equals 1/4, we need to check to see if both of our answers work. So I'm going to do a check. X equals 8 and x equals 3. It's going to be 6 over 8 minus 9 over... Oh, also, side note, both of these should be plus, right? Because it's multiplying to a positive. So it'll be negative 8 and negative 3. So it's going to be negative 6/8 minus, that's going to give us that. So that'll be negative 3/4 plus 1, which is 1/4. So that one checks out, right? You don't have to show all of this work every time, but I do need to know what you mean by checking, right? You can't just like put a check on your piece of paper and be like, yep, I get it, because I can't read your mind. I don't know if you just think negatives are cool, you like even numbers. I need to see you know what checking means. This will be negative, this is negative 3 by the way. So this will be 6 over negative 3, which is negative 2, minus 9 over negative 4. So it's going to be negative 2 plus 9/4, which is negative 8/4 plus 9/4, which is 1/4. So both check out and both work. So our solutions to this equation right here are negative 8 and negative 3. Okay? All right. We're going to do another one. Again, you can pause this to try this on your own. You can just follow along. I would put this in your notes so that you can refer back to it easily when you're doing your homework, so you don't have to, rewatch this ed puzzle. But for this one, we have a little bit more work to do from the get-go, right? We need to, right away, factor our denominators. Only one of these denominators is factored, right? Because x over 5x plus 5 can be factored to 5 times x plus 1. X plus 2 is already in factored form. And then x squared plus 3x plus 2, well, that can be factored to x plus 2, x plus 1. So when I'm writing my LCD, remember any of them have in common, so they don't all three have to have it, just two of them need it, is only counted once. So we've got 2x plus 2's, so we'll add an x plus 2. We've got 2x plus 1's, and then all we have left over is a 5, so we need to add that 5 in. Okay, so that is our LCD. 5 times x plus 2 times x plus 1. And again, we're going to leave it in factored form. So our next step is going to be to multiply. So let me rewrite this. X over 5x plus 5 equals 1 over x plus 2 plus 1 over x squared plus 3x plus 2. We've got our LCD. Now we need to multiply each numerator, every term's numerator, by the LCD. So 5 times x plus 1, x plus 2. 5 times x plus 1 times x plus 2. 5 times x plus 1 times x plus 2. Okay, again, do not multiply this out. Okay, and when I rewrite this, I'm going to write the denominators in factored form so that I can see them, what's going to cancel. So I'll have 5 times x plus 1, x plus 2x, all over 5 times x plus 1. That's going to be equal to 5 times x plus 1, x plus 2, all over x plus 2 plus 5, x plus 1, x plus 2, all over x plus 1, x plus 2. Okay? Cool thing is, some stuff's going to cancel, right? Here, 5 divided by 5 cancels, x plus 1 divided by x plus 1 cancels. So I'm left with x times x plus 2. Here, x plus 2 cancels, so I've got 5 times x plus 1. Here, both x plus 1 and x plus 2 cancel, and I'm left with 5. So if I'm going to simplify this out, I'll have x squared plus 2x equals 5x plus 5 plus 5. That's going to be x squared plus 2x equals 5x plus 10. Again, this is a quadratic. When we have quadratics to solve, because that's the last step, right? You first, you cancel what can cancel, and then you just algebraically solve what's left. So I'm just going to solve this guy. Okay, I'm going to get it equal to 0 by subtracting 5x and subtracting 10 from both sides. And that's going to be x squared minus 3x minus 10 equals 0. The way that I would factor that, again, it's got a leading coefficient of 1, so it's pretty quick to factor. What multiplies to negative 10 and adds to positive 2 is going to be x minus 5 and x plus 2. So we'll set both equal to 0 to be able to find our solutions. X equals 5 and x equals negative 2. But then, just like we did on the last one, you've got to check your work. You got to check your answers, see if things check out. So if we start with x plus 5, if we start with x plus 5 and we plug that in, we're going to have 5 over 5 times 5 plus 5. Lots of 5s there. Then we'll have 1 over 7 equals 1 over 7 plus 1 over, it'll be 7 times 6, so 42. And this is where I would suggest that you just type into your calculator, okay, this side is 5 over 30. So now I'll see, is 1/7 plus 1 over 42, is that the same decimal? That's enough work. You don't have to, do all this adding fractions by hand because you have a calculator. I just need to see that you know what you're doing, or you know why you're doing it. Okay, so x equals 5 checks out. And now we got to check x equals negative 2. Okay. And we'll plug that in. So we'll have negative 2 over 5 times negative 2 is negative 10 plus 5 is negative 5 equals 1 over negative 2 plus 2 is 0. And 1 over 0 times, I'm looking at it in factored form, negative 1. Okay, so I want you to answer this question. Does negative 2 work? No, it doesn't, right? That's undefined, right? Dividing by 0 is undefined. So if we have negative 2/5 equals undefined, that doesn't make sense. We can't even add those together. So our only answer here is x equals 5. Okay? All right. So there is, this example is also worked out in the slides if you're interested. I just have it in there. But what I want you guys to do for the rest of your time in this asynchronous class is you need to do this exit. You need to do this exit ticket. Okay, it's on Schoology. It's set up kind of like a quiz is. It's just answering this question. I want you to solve for R. Okay, this is due tonight. This is due Friday night. This isn't your homework. This is kind of, did I show up to class? Did I do my classwork? Okay. And then your weekend homework Your homework for this weekend is, oh, it got shifted down. There we go. Your homework for this weekend is the Solving Rational Equations worksheet that I assigned in class on Wednesday. It's 16 questions, and I want you to do them and upload a photo of them all as per usual. Make note that there is a little typo on number 14. It should be an addition sign right here. If you try it with the subtraction sign, you will get a really unfun answer. Okay, feel free to email me if you have questions on this, and thanks for watching.